Yeah, we're good to go again.
All right. I hope I'm audible again. So yeah, welcome guys. We'll be talking about version control systems today, in particular Git. And this will be required throughout the entire course because this is how you will, be submitting your applications and how you will be, showing us the work that you do. So yeah, I think we can get started. Before the session, I will let you know that it's okay if you don't follow along right now because you need to install Git on your system. All those instructions will be given at the end of the session, and I'll try to get through it quickly so that you guys don't have to wait for a long time. So yeah, let's get started. Um, yeah, so what is Git? So Git is the most commonly used version control system. So you might be wondering what a version control system is in general, right? So the main idea of having version control systems was to, make the job of software development in teams easier for people. So just imagine that you're creating an application, or you're creating a mobile application or a web application or any sort of application. You write some code, okay, and you're working with someone else as well. So you made some changes to your code, but that's on your local machine, right? So you're doing it on your own laptop. So how will the other person get to know of the changes that you've made on your laptop? That might not be very easy, right? One possible thing that you could do is upload it somewhere like on Google Drive or something, and they could download it from there. See what you've done. They could make their own changes, upload it again, and you could download it again. But that just sounds kind of tough to track, right? It's not very easy because you'll have to keep downloading and uploading your things every time you make a change, and that is not a very good system to have. So that's why something called a version control system was developed. So it just makes collaboration on projects much simpler, and you'll understand the importance of it when you build applications or when you build software in a team. So what Git does is it tracks the changes that you've made to your files. So you have a record of what you did and when you did it. You will also have a record of why you did it, and you will show how you have that record as well. And suppose something goes wrong in your application moving forward, you can always move back to a version that was working before, so that you never need to start afresh, right? So if you're working on some application, suppose you're not using anything, you're just coding. Your application was working yesterday, you made some changes, your application is not working today, and you can't make it go back to the previous version. Like you don't know how it went from this, like how it came to this version, and you don't know how to make it go to the previous version. So to avoid those sort of problems, we use Git, right? So it also makes collaboration very simple by allowing changes from multiple people to be merged into one source. So yeah, this sort of provides a diagrammatic view of version control system. So you have like one main branch of development that's going in the middle. So this is it's usually called the master branch. So suppose this is the entire team of the work. You have some work that you did. So you branch out of the team, you do some work on your own, and you merge your changes back into the main stream of line of code which you had. Someone else also might do the same. They might start from here and they might merge back after some time. So that is basically what Git is. I hope you got a decent idea of what Git is. Yeah, so let's move forward from here. Yeah, again, why do we use Git? I think I explained this, but let's just go through these points. So, as projects become more and more complex, with like a larger number of people contributing the same code base, it becomes necessary to have some sort of an organized way to manage your code. And that is what Git does. It makes your software development process very simple and organized. We also need to ensure that changes made by others on your team don't affect the work that you're doing currently in a negative sort of way. And similarly, the code that we are using or the code that we are writing should not affect anyone else's job in a negative way. So that is also something that we need Git for. Also, we need to protect our code against human errors. So we can do that as well, again, it's like by using Git. So yeah, let's go forward. Yeah, so this was about Git. It's like a version control system. So the main difference between Git and GitHub is the fact that Git is on your own local system. So even if you're not collaborating on a project with someone, you can use Git and it'll just make your own personal development experience pretty simple. But the thing is that it's only on your local system. So if you go on someone else's system, you will not be able to access the code that you've written. You will not be able to access the changes that you've made, why you made those changes, nothing. So you won't be able to do that. But if you use GitHub along with Git, you can do it, right? So you have the option of doing whatever you are doing from any device all over the world, as long as you have an internet connection. And that's pretty awesome, right? So let's define what GitHub is. So GitHub is a cloud-based service that allows you to manage Git repositories. So don't worry if you don't understand what Git repositories are. It's just a project that uses Git. That's what you need to understand here. So it's just a cloud-based service that allows you to manage a project that you're doing using Git. It allows you to save your code online. So that, in case you lose your code, if by mistake you reset your system or you don't have access to your machine at a particular point in time, you can do so from any other machine. So it basically stores your code on its servers and you can download it from anywhere across the world. And you can just continue like nothing happened. It also allows to do many other operations, which we'll see soon. So yeah, as I said, don't worry about what Git repositories are for now. It's just something that uses Git. It's a project. Yeah, so let's begin now. Um, so what is a repository? A repository is something that we'll talk about soon. But first, let's understand what a directory is. So a directory is nothing but just some folder on your local system. So if you go into your My Files in your Windows computer or your Nautilus File Explorer in your Linux system, you will see some folders, right? So any of those folders can be called a directory. That's just another word for a folder. So what is a Git repository? It is again just some folder on your local system, which is initialized using Git. And I will show you how you can initialize a Git repository using the git init command in the upcoming demo session which we have. Now, what is a GitHub repository? Uh, a GitHub repository is basically that same folder, which was a Git repository, but it's pushed to the GitHub platform. So as you can see on the right-hand side, this is what is called a GitHub repository. So there's this user called Jason ETCO, and he or she, they have an AutoCAD classifier project. It couldn't be any project. It's completely up to you. And their project contains these files and folders inside them. So he or she, they've just pushed their code onto GitHub, and now it's stored here. So from any system all across the world, you can go ahead and download this and start working on it again. So that's what the basic terminology for repository is. I hope you have access to the chat so that you can ask your doubts, and I hope that the mentors on the chat can answer those doubts. So yeah, we'll take some doubts at the end as well. Don't worry about that. So yeah, let's move forward with our work. So how do we initialize a folder using Git? So let me open up a terminal, and we can do that. So there is my terminal is right here. Yeah, so this is my terminal, and using this terminal, we can do a lot of stuff. So let's just create a folder for now. Let's call it Git tutorial because that's what this is. So mkdir Git tutorial. What this does is just creates a folder for you of the name Git tutorial. So it's an empty folder for now, and you can use this folder to put whatever files you want in it. So I'll enter this folder using cd. These are just commands for the terminal. You will learn them as you keep going through your college. So yeah, cd Git tutorial. You've entered the Git tutorial folder, and now let me just create some file over here. So let me just create a notepad file. Let's call it file1.cpp. So file1.cpp is nothing. It's just a file which is called file1, and it's a CPP file, which is a C++ file, and that's a programming language. You don't need to worry about what that is for now. Let me just type up some very basic code for this. Yeah, so you don't need to worry about whatever I'm typing right now. You can type hello world or you can type anything you want. I'm just putting up some basic boilerplate code so that it gives us an authentic feel. So yeah, we've created a file1.cpp. Now cat
Compiling
file1.cpp.
it.
Sorry.
We are not compiling it anyway, right? So why do we need to write valid C++ code?
Yeah, we don't need to. I'm just doing it for the sake of nothing really. I mean, we might as well type anything, so we don't need it. Yeah, so moving forward. Yeah, so this is the contents of our file1.cpp. Whatever we typed just now, you can type anything, but that's what this is. So yeah, now let's just initialize this as a Git repository, and you can do that using the git init command. So it tells you that you've initialized an empty Git repository, and you can move forward from here and perform Git operations. So let's just go back to the presentation. Over here, you can see whatever I did just now as a screenshot. So yeah, this is done. Now let's take a moment to understand how Git and the GitHub flow works. So you're working on your local system uh, to make changes. So suppose you've made some change in your working directory. So now that change you might want to reflect in your GitHub repository, or you might want to add those changes or commit those changes. So what that means is basically, suppose you're working on some feature, right? Let's say you're working on a feature to create a map for your application. So once you're done with creating that map, you've tested it, it works properly, that's great. So you want to store that inside your Git. You want to, put that on your GitHub repository so that others can see your code, and they know that you've done some work, and they can download it on their systems and work more on that, or work or include that inside the application or whatever. So you want to do that. So how do you do that? There's basically something called a staging area. So here, all your files that you want to commit or that you want to put on your GitHub repository, they will be staged. So you can add those files using a git add command, which you'll see soon. Once those files are added or staged, they're inside the staging area. So now, once they are staged, you might want to commit them. Once you are sure that you want to put this change on your GitHub repository. Okay. Before moving forward, I would just request you to mute yourself if you don't have any doubts, so that there are no disturbances. Yeah. So once your app is in the staging area, you might want to commit it. So once you commit your files, you will need to. So before committing, you need to actually provide something called a commit message, and that commit message will contain a small description about why you are committing or adding these files to your repository. So in my case, I was developing a maps page in my application. So I will say git commit developed maps page. So that string will tell me why I made those code changes in my application. And that is actually the why of you made some changes. So we saw what changes are made, when those changes are made, why those changes are made, right, in the earlier slides. So that's the why. That tells you why some changes are made in your development process. So once you've committed your changes, it's still on your local machine. You have not pushed it to GitHub, right? So if you want to push it to GitHub, there is a command called git push, and whatever commits you have made on your local system, those will be pushed to your remote repository that is on GitHub. And once this push process is done, this push process, once it's done, then anyone across the world, if your repository is public, that is, you've not made it private to your own page, if it's public, anyone can see those changes that you've made. And even you, if you're working on some other system, you'll be able to see that you've made those changes at this particular time. So that's basically a little bit about the flow of Git. So just to recap, add, then commit. Both of these things happen only in your local system. And then once your commit is done, you can push it to your remote repository, and then your code is published online. So yeah, so let's just say your code is published online. So now, suppose I'm Igjot and Rashmit is sitting somewhere else in some other city. So I, Igjot, have made some changes on my system, and I've pushed it to the GitHub repository. Now Rashmit, he's also working on the same project, and he wants to see what all changes I've made. So what he will do is he will fetch those changes from the GitHub repository, And those changes which I pushed recently will come on his system and he can view them on his own local machine. Yeah, again, I would request you to mute yourself if you don't have any doubts. Yeah, so once you've fetched those changes once Rashmit has fetched those changes onto his local machine, he can build on that or he can use that to develop something else. And that's the power of GitHub. So basically, this is how collaboration happens. So I develop something, I push it to GitHub. Someone else who's on the same team as me, who's working on the same application, is going to look at those changes and bring those changes into his own system. And then he can make changes to that in his own way. So that's what fetch does. And there are multiple other commands that we'll be looking at. So yeah, this is basically the GitHub flow. So yeah, so what we've done now is we've just initialized our Git repository, right? So we want to, at any point of development, if we want to see what the status is, like if we have added some changes or if we have committed some changes, we can use a command called git status. And that will basically tell you of, which files you've added, which files are yet to be added, which files you've committed, and so on. So let me just type git status. So what this does is it tells you which branch you're on. Again, this is something that I'll be sharing with you later. It tells that we've not made any commits yet, which is true. We've just initialized the Git repository. Now it says untracked files. So this basically means that this file, which they've put here in red, file1.cpp, this file has not been added or staged yet. So if we go back to our previous slide, we are still inside a working directory. We have not put it to the staging area as of now. So let me do that, right? So to add something to our Git repository or to add some changes, we can use something called git add. So git add, and we can specify the file names which you want to add to the staging area. Now, you might not want to add all the changes that you've made. So you can actually just put the file names that you want to add, and only those changes will be reflected in your commits and further pushes to the repository. So here, if I want to just put file1.cpp, actually that's the only file I have. So I can do git add file1.cpp. So I press enter and that is done. So now that I've added this file, let's just do git status once again and see what our current status is. So yeah, so we're still on branch master. We've not made any commits yet, which is correct. We've just added some file. And now you see, right, there are no untracked files. It says that there are some changes to be committed, which means that this file, file1.cpp, it has been staged in the staging area. And now we are ready to commit this file. So let me just commit this file then, git commit -m. This is just some syntax, right? So git commit is the syntax for committing any changes that you've made in your staging area. So once you do git commit -m, this M stands for message. So inside these double quotes, you will put whatever message you want. So, I'll explain why I made this change. So I'll say I created new C++ file. And you'll get some feedback based on that. So it'll tell you that you're on the branch master, which I'll explain later. It'll tell you the message. It'll show you how many files you changed. In this case, we only changed one file, which is we created it, and we added 5 lines to it. So this is 5 insertions. So yeah, that's great. So now our current file is inside this local.git repository stage. We have committed it from the staging area to this local stage. So now, we might want to push this to our GitHub repository, but we've not even, created any repository yet. So let's do that, right? So let's go to GitHub. So this is my GitHub page. Over here, I can see my timeline. So these are the people that I'm following. So I'm following some people. I'll get to know who follows me. So I'm following someone called Herschel, and I can say what all he has done. And this is basically the home page. If you want to create a new repository, you can go to this new button and you can create your own repository. So over here, let's just create a repository called Git tutorial. You can give it any name as long as it conforms to the GitHub standard of names. Let's just make it, okay, yeah, why not? Let's keep it public for now. You can put in a description if you want, and you can add all of these files. We don't need to worry about what all these are for now. Let's just create the repository. So what we did just now is that we created a GitHub repository, and now we can push from our local system So we can push the Git tutorial folder onto our GitHub repository. So let's do that. So let's move forward. Let me just go to the slideshow mode. Yeah, let's push to GitHub. So for this, we need to create a repository on GitHub. We've done that, right? So I've created a repository called git_tutorial. So we can add the remote to Git repository to tell Git which GitHub repository to use. So yeah, that sounds very confusing. So let's just take a look at that. So this is the URL for our repository. So this github.com/ikjot-2605. This is my username for GitHub. And this is the repository name. So this is the URL which we have. We copy this from here, and then we go back to our terminal. So now what we can do is we add something called a remote to our Git repository. This is our Git repository because it's on our local system. It has nothing to do with GitHub right now. So to our Git repository, which is on a local system, we can add a remote origin. And that origin will basically be linked to this repository on GitHub. So this URL is going to be linked to this repository. And we can use this URL in our Git repository to like tell them where we want to push our code, where we want to pull our code from. All these kind of things can be done by giving it a remote. So for that, we can do something called git remote add origin. What this does is it adds a remote. It's just an identifier. So a remote is like an identifier, and it'll tell you, which repository on GitHub to use. So now we paste this URL which we got from our newly created GitHub repository, and let's press enter. So that's great. I mean, this means it worked. Now we can do something called git remote -v, and it'll tell you that you've added something called an origin, which is a remote, and this is the value for that origin. So this is the repository that we're going to be pushing and fetching from. So that's great. We've combined our Git and GitHub both together now. So let's move forward. Yeah, so now we can push our code, right? So we have to push our code. Just to give you, just to give you a refresher here, we are currently in the local stage. When we push, we will push our code to GitHub. So let's do that right now. So we want to push our code. We will use something called git push for that. And we have to specify a couple of things here. So I will type it out and I'll explain it to you. So git push origin master. This is what we're going to be using to push our code to our GitHub repository, which is on the internet. So what this will do is it will push whatever changes we have made, whatever commits we have made, to be more clear. So whatever commits we have made, suppose we have made multiple commits, we want to push all of those commits to GitHub. So we can use git push origin. Origin is the name of the remote that we just added. So origin will tell Git, okay, I want to push it to this repository, which is identified by this URL. So we want to push it to the repository that we just created now. So we have added the remote for that, and we want to use that to push. So we specify the origin here, and master is the branch. Again, branch will be explained very soon. But for now, this is the name of the branch that you want to push. So let's just do that. Since I'm already logged into GitHub from my command client, I don't need to worry about this too much. It'll usually ask you for your credentials for GitHub, but we don't need to worry about that right now because we're not. I've already logged in, so that's fine. So it's pushed to GitHub. Now let's go back to our GitHub repository. Let's refresh. Let's see what happened. So great. You can see that this file1.cpp has appeared over here. And you can see that this code was what we had put in our local system, but now it's shown in our GitHub repository. So that's done. You can see how many ever commits you've made on a particular branch. And over here, we can see one commit. You can press on this and see all the commits that you've made. And yeah, so that's great. We have pushed our first commit to GitHub. That's great. Let's move forward now. Yeah, so let's try to understand what branches are before we move forward, because branches are very important to understand the workings of Git and GitHub. So what is a branch? A branch is like a single line of development So, when you're developing applications, you'll have one main line of development, which will be usually called the master branch. And that line of development will only be changed when you are completely sure that the changes that you're making are valid. So in real life applications, you want to change the master branch only when you have tested properly and you are completely sure that this will not break our code. So that's like your main branch, your main line of development. You can have many lines of development in your project. So you can have multiple branches inside a Git project. So some of the use cases of developing new branches or creating new branches might be like if you want to create a new feature, suppose, or you want to fix a bug that currently exists, or you want to create a new release for your application. All these kind of things are they basically warrant a change or a branch change basically. So if you're creating a new feature for your application, suppose a maps feature, you will branch out of your main app of your main line of development. So let's say this blue line is a main line of development. You will go into a new line called the feature branch, feature maps branch. You will make those changes over here. So this is like a change that you made, and you can go back to your main line of development over here. So you made that change on a separate branch, and once those changes were tested properly and ensured that they work, they can be merged back into your main line of development. So that's what a branch is. And the main reason why you would want to use a branch is to ensure that nothing breaks in your code when you make new commits. So yeah, so the main idea is to modify existing code only when we are sure of the validity of the new code. That's the main idea of branches. So yeah, let's go back to our terminal and mess around with branches. There is some sort of an issue actually. Yeah, okay. Yeah, hey, you can hear me, right?
You're audible, Ekbo.
Okay. All right. All right, cool. Yeah. So yeah, so moving forward, let's talk about what branches are and let's see them in working. So uh, there's a command called git branch, which will show you all the branches that you have, all the active branches, I think, and it'll show you the current branch which you're on. So since this was a new Git repository, we've not really created any new branches or anything. So when we do git branch, it'll just show us master branch, and it'll be put in this green color. So the star means that this is the current branch that we are on. Now let's create a new branch, right? Let's say we've created the CPP file right now. It's an empty CPP file. There's literally nothing in it. So we want to suppose print hello world in our CPP app, right? So since it's a new feature that we're adding, let's just create a new branch. So let's do git checkout -b and give a branch name. So let's call it feature -hello world. So what this statement will do is it'll create a new branch called feature hello world, and git checkout -b means that this is a new branch that we're creating. So there's no branch called feature hello world as of now. If this -b was not there, then we have to specify a branch that already exists. So we'll also take a look at that soon. So git checkout -b feature hello world. So it switched to a new branch called feature hello world. So now if we do git branch, let's see what happens. So now you do git branch, you see that there are two branches now. One is a feature hello world and one is master. And the star is next to the feature hello world, which means that this is your current branch that you're working on. So yeah, so actually let's go and implement that new feature that we have, right? Let's just do that. So let's open our file in Notepad, file1.cpp. And inside our main, let's just print hello world. So if you don't understand what I'm doing right now, it's completely fine. All I'm doing is I am telling the C++ program to print hello world when it is run. That's all I've done right now. So I've saved my file and I'm closing it. So now if I do git status, it'll tell me that I've modified file one, but it's not added yet or it's not committed yet. So let's do that, right? So let's do git add. Let's do git the add dot right now because this is the only change that we have. Once that is done, we can commit our file. So we can do git commit -m and we can say hello world feature implemented. And our so our commit is done. Now we can just we can push this onto our GitHub repository. But again, so now one important part here is that we will have to push it to which branch? That is also a good question, right? So let's just do that. Let's git push origin. And since we are using a new branch called feature hello world, let's specify that over here instead of our master branch, because we don't want to push anything to master before it is completely tested and verified that it works properly. So let's do feature hello world. Now, in our GitHub repository, we will be able to see a new branch, hopefully. If you've done everything correctly, let's just go ahead and take a look. Yeah, so as you can see, now there are two branches. One is the master branch, which is the main branch of development, and one is the feature hello world branch. And now you can see this box over here, and this says compare and pull request. We will talk about this soon, but let's go back to our presentation for now. All right, so we have seen what branches are. We've added the feature as well. So on a new branch, we make the change in file 1.cpp, and we stage and commit the change. We've done all that. Now that change has been done on a feature branch. So that change has not been done on the master branch. It's only on the feature branch. And suppose we want to change this. We've tested our code on the feature branch, like our feature hello world branch. We have completely gone ahead, tested that code, verified that it works correctly. And now we want to put that code back into our master branch. So how do we do that? Because we just want to merge those changes from our feature branch to the master branch. So we use something called git merge, and let's see that in the upcoming slide. So we can merge changes from one branch into another branch by using this git merge command. So right now we've made the change inside our feature hello world branch, and we want to merge that into our master branch. So one important thing that we need to keep in mind is, so let me just go ahead and show it to you visually so that it's easier for you to grasp. So let's say we have a branch of development here. There is multiple commits that you've made on a particular branch, and you move out of this branch and you go into another branch. So this is some feature branch that we have. Suppose these are all commits. So by the way, these boxes that you can see, these are all commits. So this was your this thing was your main branch, your master branch, and this is your feature branch. So once you are sure that your feature branch works correctly, you want to put it back inside the master branch, right? Let me just use. Yeah. So you want to push this. You want to make these changes, feature branch changes, into your master branch. So you want to do this. Basically, you want to go back to this line of development, and that commit of branch, like merging, will also come over there when we merge our branches together. So one thing to keep in mind here is that we are currently using our master branch, right? So the master branch is our parent branch. We have branched out of our parent branch and moved into a feature branch. So when we want to merge changes from the feature branch into the master branch, we need to go into the master branch first. So we check out into the master branch, and then we merge those changes from the feature branch. So let's go ahead and do that. So we've made those changes inside our feature hello world branch, but to look properly, we have, so we're currently on the feature hello world branch, which is not where we want to be, right? So if you want to merge changes, we have to be inside the parent branch, and that is the master branch. So let's go inside the master branch. We can do that using git checkout. And as I said, for a branch that already exists, you don't need to use the -b. So when we created a new branch, we used this -b thing right over here. We don't need to do that in case we are using an already existing branch. So let's go git checkout into master. And yeah, let's basically merge those changes now. So we merge the changes from the feature hello world branch. Hello world. And these are not underscores, these are hyphens. Yeah. So we git merge feature hello world. And then you can see that the merge was completed without any problems. So it says that it was updating. That means that the commit was added into the master branch. and one file was changed, there was one insertion, and there was one deletion. So that's basically what we have done now. We just merged those changes inside our master branch. So if we do a git status now, everything is fine. There's nothing to commit. That's great. So this is done, but you see this fast forward right over here, this fast forward. You might be wondering what that means. So let's just take a look at that as well. So there are two types of merges that happen. One is a fast forward merge and one is a three-way merge. So in the fast forward merge, there is just a single line over here, right? So we worked from commit 1 to commit 2 to commit 3 in the master branch. Then we decided we want to add a new feature and we moved into a new branch. So there's a feature 1 commit, feature 2 commit. And once we were on feature 2, we were sure that the feature is done, it's working perfectly, and we want to put that inside our master branch. So as you can see, the master branch was not updated uh, when we reach this F2 commit. When we want to put merge those commits back into our master branch, the master branch is still on this commit 3. There was no commit 4 added when this thing was being developed. So when something like that happens, we can use something called a fast forward merge, where the master branch just moves from this commit to this commit. And that is basically all that happens. You just change this pointer to go from this master branch C3 to this F2. So that's the fast forward merge. But in case there was something like a commit 4, which was added while this feature was being developed. So right now this F3 is developed, but we had branched out of C3. Now there is a C4 as well. So in this case, we will need to use something called a three-way merge. So these are just two different type of algorithms which are used when merging, two branches. And Git does that automatically for you. You don't need to worry about it. So in this case, since our master branch was not updated when we were developing our feature branch, a fast forward technique was used. And yeah, so that's great. So so there's an important part now. So there's something called pull requests on GitHub. And yeah, so let's look at that as well. So now uh, our code works properly. The master branch is supposed to have the code which we changed just now, but we've not pushed that onto the GitHub as of now. So let's just go and do a git push origin master, and yeah. So if I'm not wrong, it should have updated. And yeah, so you just push those merge changes into our repository. And now you can see that we have this file which was added, this line which was added inside our, while we were merging our thing. So yeah, so that's great. Now, once our master branch is updated, we might want to add a new feature. So like if a user logs in, we want to greet the user with his name or her name, So let's just create a new branch for that. Since it's another feature, we'll create another branch called git checkout -b greeting. No, so this is a branch name. So feature greeting. So we've created a new branch. Now again, we can open up our file, file1.cpp, and we can make those changes. So we don't want this hello world now, right? We just want to greet the user. So let me just make those changes quickly. We take in the username. This code actually does not need to mean anything. I'm just doing it for the sake of doing it. So we can ask the user to enter their name. We can take their name and then we can print out hello and their name. So we'll say hello. And we can put their name here. So yeah, we have created the feature now. The feature, we've checked that the feature is working. So we want to push this to our feature greeting branch. So we'll do a git push origin feature greeting. So we've pushed the feature greeting branch to GitHub. Let's just go see if that was done or not. Yeah, so you can see, right, this feature greeting is here. Okay. Okay, yeah. So there's a mistake that we've done here. So we've not added or committed those changes that we've made, right? So we did some changes inside our notepad, inside our file1.cpp, but those changes were not added or committed. So Git does not know that there were any changes made. And that's why I did not push anything to our branch. It only pushed the master, whatever was on master right now. So to do those changes, we can first actually look at git status. It'll tell us that we have modified something but not added it or committed it. So we'll do a git add dot. We'll do a git commit -m greeting feature added, and we can do git push origin feature greeting. So now that we've added and committed those changes before pushing, we can see that the greeting feature was added. And when we go inside the file, we can see this. We can see the changes that we had made inside our code. So if we go back, we can see this yellow box again. And we had looked at this very briefly in the slide, that there is something called a pull request. So when you make changes in branches, right, like when different users in a project make changes to branches, you can create pull requests, and then some approvers will look at your code. They will approve those pull requests and merge that code into a particular branch of development. So suppose you were on the master branch, you made a feature, you pushed that feature onto a different branch, like a feature greeting branch. Now suppose my boss or someone, let's say Ishan is my boss. So Ishan looks at the code that I've written. He looks at my pull request, and if all the changes are working fine, if he feels like everything is working correctly, he can take that pull request. He can merge my changes into the master branch from this feature greeting branch. So let's just me as a user, I will create this pull request. So I've made some changes in my code. I can give it a name. So like I can say added the greeting feature as the name of the pull request, and I can leave some comments here for the approver to read. And I can say create pull request. Over here, you can see that we are trying to make those changes go from feature greeting into master. That's what the pull request is. We create the pull request. And now inside this pull request tab, you can see the details of our pull request. So greeting feature was added. And now since, so in this repository, I am the owner. So I am my own boss. So I can merge my pull request. So if I go and merge my pull request, my master branch will get changed. So let's just look at our master branch before and after merging so that you have an idea of what will happen. So our master branch, before those changes get merged, is just see out hello world. This is our master branch. Now let's go into our pull request. This is our pull request, and it'll tell us that this branch has no conflicts with the base branch. The base branch is master branch over here. So we merge the pull request by pressing this green button, and we can confirm our merge. This will be like the commit message for the merge. So we confirm merge, and it'll tell you that the pull request was successfully merged and closed. So we can go into our code now. Now let's see what happened to. So this is the master branch. I just merged the pull request from my feature branch into my base branch, which was my master branch. Now let's see if it was changed. So yeah, you can see, right? All of this data was changed here. And that's the beauty, right? So if you are working inside a team, you can make your changes. Someone who is at a higher level, then you can review those changes, and then they can approve and merge those changes back into the main branch or master branch. So that is a little bit about pull requests. You will be making pull requests to submit your assignments. So I suggest doing some practice on some test repositories like this, so that you have a good idea going forward. Yeah, so I think we've all seen this. Let's just move forward. So yeah, this was a pull request page. Okay, so yeah, in the pull request, we actually didn't see one thing. Let's just go back and see that we had closed it. Let's just take a look at it. Yeah, so when you go into your pull request, right, there is something called files changed, where you can actually see all the changes that are made. So my boss or the person above me at an above level who's responsible for reviewing my code can come to these files changed tab, and then he can look at what changes I made. So I just deleted this one line of see out hello world, and I've added 4 lines. So they can actually look at all of the files that I've changed. Over here, there's only one file called file1.cpp, which I've changed, but there might be many changes that you made, right? So you can look at all those file changes, and then you can look at the exact changes that you made in each file. And if you want to leave comments, you can leave comments as well. So you can say that this is wrong or something, and you can leave reviews over here. and the developer will fix those and commit more changes into this pull request, and then they can be merged once the approver is satisfied with all the changes that are made. So this is the files changed tab, which I did not show earlier. And this is the commits tab. So yeah, you can go ahead and look at those commits later on. Okay, so we're almost reaching the end here. Again, one more important thing that we need to do is something called forking. And forking is important due to many reasons. So GitHub is like a social media for developers, right? So you can showcase all your projects, and you can showcase all of the application that you made, the websites that you made, some of your interesting ideas. And those kind of things, you might not want anyone to be able to change those things, right? So everyone can see your code. You might make your repository public for everyone to see, but you might not just allow anyone to change your code because they might make it incorrect or they might do something wrong to your code. So what most people do is the owners of repositories, they don't allow anyone to write to the repository. So they allow forking, which is basically a process where you can take a repository. Like I've taken the Flutter repository. So just for your information, Flutter is an open source repository that you can see on GitHub. So all of the Flutter code, like the framework code which they have, is available on GitHub. So you can actually see all the commits that they've made. As you can see, there are 27,000 commits on the Flutter repository. And that's kind of a lot, right? So that basically means that's the power of open source. Like if you have enough people working on a particular project together, you can have a good, a really great thing coming up out of nowhere. So that's a little bit about open source. So yeah, you're not allowed to make changes directly to Flutter unless you are a contributor on their repository, and those changes can be made if you fork the repository. So like over here, I have forked from the Flutter repository, and when you fork a repository, right, a copy of that repository is made in your own account. So as you can see over here, Igjot-2605 is my username. And in my account, there is one new repository called Flutter. So when I pressed fork, there's a button called fork over here, as you can see. When you press this button, it will create an exact copy of the Flutter repository into your own account. And those changes, you can look at all the files inside that particular repository. You can make your own changes into your own personal repository which you have inside your account. And if you want to make contributions to the actual Flutter repository, you can create pull requests from your own repository into the actual Flutter repository. So you can make changes in the code. You can add them, commit them, you can push them onto a particular branch. And once you're happy with the changes that you've made, you can create a pull request from your own branch that is on your own account, and those changes can be or will be available to be merged inside the actual Flutter repository. So yeah, when we fork it, it will be stored in our own, not in our local repository. You can obviously download it, but it will be stored on your GitHub account. So it will be on the GitHub, not just your own thing. So yeah. Yeah, so basically that's a little bit about forking. You can make changes and do all that kind of stuff. So essentially, the forked repository that you've created, Igjot-2605/Flutter, is mine now. So I can make whatever changes I want to that. But those changes will be reflected in the actual Flutter repository only if it's merged, only if a pull request that we've submitted is merged. So it's kind of like a difficult process to understand, but once you've done it 2 or 3 times, you will have an idea of how it works. All right, so here are some more other important commands. We won't be going into too much detail here. Just to give you an idea, git pull is one command. So what this does is it fetches all the changes from the remote repository on GitHub. So suppose I've made some changes on my system and Rashmit wants to see those changes on his system. He will do a git pull that will download all the changes into his own system, and it will automatically merge as well, as long as there are no conflicts. If there are some conflicts, conflicts can be explained later. It's like a little bit difficult concept to understand right now. But just to give you a brief idea, conflicts are when you change the same line of code in two different branches. And when you try to merge those branches, there'll be a conflict because of that. So, GitHub does not know which one to use because it's not sure which chain is correct. So it allows you to make those changes manually, and then you can commit those changes again. So git pull will allow you to download all the changes that have been made by other users into your own system. And git pull remote name branch. So there are two variations of this command. Git pull will just download all the changes. And if you want to download a specific branch changes onto your system, like if I'm working on a feature branch and I want to download only those changes into my system, then I can do git pull remote name, which is usually origin, which we had given it in our current demo. And we can specify the branch which you want to pull. That is something. There's another command which is very, very important and very widely used, which is called git clone. So if you see any, interesting repository on GitHub, like you want to explore what that repository does, or you want to run it on your own system and see, make some changes and see how those changes turn out on the application or on the repository, you can use git clone, which will download that particular repository on your system. You can make changes to it locally, and you can run it and see how that affects stuff. So that is git clone. It just downloads a remote repository onto your local system. Um, Now there is another command called git stash. So let's say you've completed a particular feature. You're done halfway through a new feature. Like you want to create that maps page, right? So you're done halfway through creating that maps page. Now you and you're working. So it's like a checkpoint. If you've played some racing games or something, right? You might realize that there is something like a checkpoint, which you start from if you die in the game going forward. So it's kind of like a checkpoint. So if your code dies, or if you make some mistakes in your code and you want to go back to the last working thing, you can use git stash. So if you made some changes that you've not added or committed yet, you can use git stash and it'll go back to your previous working commit. So that's what git stash does. Um, Now there's something called a git diff also. So between two branches, you can figure out what all the differences are, and that is using git diff. I'll just give you a very small demo for this. So if we are, let's see what branch we're on. We are on a feature greeting branch. So let's do a git diff between feature greeting and feature hello world. Let's see what happens. It just basically tells you the difference between the two branches. So as you can see here, it'll tell you that the changes are in this file called file1.cpp. And the changes are that the feature hello world branch has this line, which is in red, which is not there in our branch, which is the feature greeting branch. And in our feature greeting branch, we have these extra lines, which are not there in the feature hello world branch. This is what git diff does. It just shows you the changes that differences between two particular branches. And it's also very useful when you're reviewing stuff. So yeah, these are some important commands. As I said at the starting of the session, I'll explain to you. Yeah, so you can install Git on your own system, and you can do that using the following tutorials, and you can look at the documentation for extra steps and stuff. So yeah, you have a basic idea of what Git is, what GitHub is, and now you can go ahead and explore more. I've linked to a couple of good documentations along with the install instructions as well, and you can take a look and do that. So thank you. If you have any doubts, put them up on the Flutter Doubts channel, and you can also unmute yourself and ask those doubts now. If there was something that you did not understand, yeah, go ahead.
Yeah. Just to add on to what Ijjot said, all those commands he mentioned, no, those commands need not be remembered, and those, we don't remember those commands as well. We just Google it when necessary. So one more thing is we understand that like it's not a follow through session. This session just demonstrates how each command works. You can just watch this video again and again in your free time, and we do not require this session to be completed or to be understood for any upcoming session. So Git is something you will learn in your development journey. None of us knew Git even when we were in the bootcamp in the first two sessions. So even if you you got the basic idea, I hope by the session. So do not be frightened by the terminology. That's all I want to say. Yeah, and you can put your doubts now.
In many GitHub repositories, we also have something called .github, right? So hello?
That's for config. Yeah, that's for configuring. Am I audible?
Yeah.
Yeah. So .github is for configuring certain things. Like you can have some pull request templates, or you can have some issue templates. You can also have workflows. If you saw the charts, I had mentioned about GitHub Actions.
The
So
voice
you
is
could
breaking.
use that to configure workflows, like CI/CD pipelines you can create. Yes. You are something?
Yeah, your voice was breaking when you were telling that it's for configuring something.
Okay. Is my voice clear now?
Yeah.
Hello.
Yeah, it's clear.
Yeah, you're
Yeah.
audible.
So .github is to configure pull request templates or issue templates or configuring CI/CD pipelines. Like you can run certain workflows using YAML files. I mentioned about GitHub Actions, right? So you can use that also. You can use that to configure. You just have to write YAML files and you can run CI/CD pipelines on that.
Okay.
Yeah. So I think Igjot showed you the Flutter repository, right? So you can take a look at that. So there you can see some pull request template or issue template or code of conduct, right? You can have all such things mentioned. So what will happen is GitHub will take out those. So in the UI, it will show you, it will link that up. Like on the right hand side, if you see, right, there will be a link to the license, code of conduct, and stuff like that, right? So it will pick up properties from the .github folder.
Okay. Get it.
Yeah.
What's the
Guys,
difference?
we'll follow the. Yeah, go.
What's the
Sir, when
difference?
will we be able to access the recording of this lecture?
It'll be available once the session is done. So the recording will be available in Teams itself, so you don't have to worry about that.
Can we leave now?
By when are
Yeah,
we
you
supposed
can
to
drop
get
off if you.
Flutter and Git
Thank you
and
very much.
GitHub accounts ready for like the sessions?
I think
See
Ashok
the yeah. So we'll create a GitHub repo, and you guys will be having access to it, and we will provide you with assignments after the right after the next session. You can work with that repo from here on, from there on, sorry. And yeah, so you guys, like, if the git doubts are over, if someone is facing problems with installation, they can stay back, others can leave if git doubts are over. If you have, you can continue with doubts. Yeah.
And also, Ishan, can you just stop recording? I think it's only doubts after this.
Yeah, I'll do that.
Yeah.